All right, it's recording. Here we go. 14BC. So we're now in binomial. So before was chapter 13 discrete. So we understand something that's countable, something that you know how to find expected value, you know variance, and you understand what standard deviation is. Now, we learned that chapter 14 was binomial and had to have a Bernoulli sequence. You're now learning the expected value, so how to find the average, find the variance, standard deviation, and then read the distribution of a binomial distribution. So here, what you see is, first thing is you need to be able to describe the type of graph. So you can see when the probability is 0.2, so chance of success is 0.2, you can see that the data kind of has this 0.2 skewed. Like most of your data kind of sits at a 0.2 because the chance of success is where it sort of revolves around. And then at 0.5, you can see that chance of success, if it's 50% chance, then most of your data, as you're flipping it, it would be somewhere closer to 0.5. Obviously, the larger the number of trials you do, the more accurate or closer it is to the actual probability. Yeah.
So why are we saying it's positively skewed if the number is positive?
Because we're talking about the tail end.
Oh, okay.
So it's skewed in the positive direction. So it's skewing means like you're pulling it in that particular direction. It's skewed to the positive direction, but yes, most times when you're first learning it, it's counterintuitive. But we're talking about the tail end, what's being skewed. Yep. So most of the data is sitting here, but it's skewed in that direction. So hence this is called negatively skewed, positive is skewed, and then relatively symmetrical. Okay? All right, so you got your shape of the distribution that they may ask. They may give you the graph and they get you to visualize or interpret where the general mean is or what the probability of success could be. Today's lesson, I'm going to get you to practice being able to distribute this on your CAS if you were to do it. So I don't think they always ask, but sometimes on a SAC we can ask you to learn to distribute it and then visualize and sketch. Okay, so how do you do it? Now you can do this individually on your CAS calculator by just doing find probability of success. If n equals 8 and probability of success is 0.25, what's the chances of x being 0? Okay, so whatever x is, I don't know what the random variable represents at the moment, but let's just say, if you were to calculate, you can do binom PDF here, binom PDF here. So I'll show you on the CAS what it looks like. So you could do something like this. You can do menu, probability, distributions, binomial PDF, so menu 55A. And number of trials, we had 8, was it? Was it 8? Yep. Probability of success is 0.25, and then x equals 0. Enter. And you can do it that way, and you can do it one each time. So you can do the next one like this. You can do then 2. You can do it that way. The other way is that I'm trying to teach you to do a spreadsheet where you get them all in one go, and then you distribute it to visualize. So here you then go add, instead of doing what I just did there, add a page, go to listed spreadsheet, label them. So let's go 0, 1, 2. Now you can keep typing, or you can do what they call field. So if you selected a cell, go to menu. Oh, sorry, I should press shift and just highlight those three. Menu, data, field. Okay, so once you're in the spreadsheet, if you do 1, 0, 1, 2, and then you go to menu, data, and field, you can now just stretch that down and you can go as far as you want. So I can go all the way to 14 and they'll just do that for me. Okay, so that's a bit quicker to do that, but we obviously want 8. We only want 8 of them because I think I put, n equals 8. So I'm just going to delete 9, 10. So I've got 8. Next one. I want you to then write the labeling just to help the x-axis and y-axis. Let's call this the x random variables. And then column B, I'm going to call it DIS, or distribution. Now, instead of calculating binom PDF for this, binom PDF for this, binom PDF for 2, you can actually just type in a rule in the cell underneath it. So here, if you just did equals menu, statistics, distribution, And you can see again, you've got binomial PDF there. Okay, so again, menu, statistics, number 4, distributions, number 2, and binomial PDF. And here you can do the same thing. You say 8, probability of success, and that should be column A. Does that pick up? Oh, wait. Oh, that's right. I need to change my setting. Menu to settings, calculate to approximate. There you go. And that way you get all your decimals in the same way, but you get them all down. Okay? So if you were to fill out a table, you could do that. And then if you want to visualize it and they ask you to plot it, then that's where you do control, add a page, data and statistics. There's your data. On the x-axis, that represents your x variable, random variable. And then you need your probability or your distribution. There you go. And then you can sketch that. So I think in general mathematics, they probably do this a bit more. So you'll probably know how to do that data. Otherwise, yeah. So you can analyze that. It should still come out, yeah. It's just visually it looks... Sometimes they might get you to sketch. They might give you a graph, like a grid, and then you have to plot. And then later on analyze them something. So they might get you to analyze their distribution. I haven't seen it many. I've seen it in SACs before, but I haven't seen it too much in an exam. All right, let's do this one. So next one. So remember the notation to say that you have a binomial random variable. So x and that symbol here, that means distributed. Okay, so x is distributed binomially, and you then write in the number of trials, and then P, probability of success. I'm probably just going to finish off just in this first example here, and then we'll continue on next session. But here's your formulas that I want you to have. So remember, there are different formulas for different chapters. This is the expected value formula for chapter 14 if it's binomial. So if it's binomial, it's number of trials times the probability of success. Whereas chapter 13, out of curiosity, anyone remember, how do you find the mean in chapter 13 again? What do you have to do? Very good. It's the sum of the x random variables times the probability of the random variables. Okay? This is chapter 13 theory. This is chapter 14 if it's binomial. So if it's binomial, you then use n times p. Variance. What was the variance computational formula from chapter 13?
E of x squared minus e x squared.
Beautiful. This is the computational formula. And if you want to know where the rules come from, then there's a theoretical formula for it, right? This one, P, N, P, Q, what's Q? Q represents the chances of failure. So P is the probability of getting what you want. Q is the probability of getting what you don't want. So we usually say NP times 1 minus P. Okay? And then standard deviation, which has always been the same, it's the square root of variance. Cool? Now, let's do textbook question, exercise 14b, question 7. This one, they've given you the mean and they've given you the variance, but they want you to find N and P and then find probability of x equals 7. Now, I normally tell you to have a go at this, but we've got a few minutes left, so I'm just going to guide you along the way. Starting off, what's the formula for the mean again? NP. So this is binomial. So they already said it's binomial, so I know it's n times p, and I know it's meant to equal to 12. So I should have an equation, NP is equal to 12, so that's equation 1. Then the second one, they tell you the variance. Variance, which we got as variance of x is equal to n times p times 1 minus p. It's meant to equal to 9. So here's your second equation. N dot p 1 minus p. Now I'm going to get you to think a bit. So I've guided you up to this point. You got equation 1, you got equation 2. The question is to find n and p. You've got 2 equations, 2 unknowns. How do you solve it? Divide by 1. Multiply by 2 divided by 1. Oh, sorry. You're saying get equation 2 divided by 1. Okay, so let's try that. So you have 9 equals n times p over 1 minus p. And you're essentially dividing it by 12. And then this one np. Is that right? Cool. So can you see, since you can divide both sides by 12, so whatever you do to one side, you do to the other. But then 12 is equivalent to np, so we're just swapping it to become np. And the reason why is because that will cancel out. The alternative is you could have also used substitution, because np is equal to 12. You could just substitute it here. Just replace np with 12. So if you replaced it with 12, would have been the same idea. You would have got 9 equals 12 times 1 minus p. Divide 12 on both sides, and you still get the exact same thing as Neil was saying. You get 9 on 12 is equal to 1 minus p. Same idea. Okay? 9 over 12 is the same thing as writing, what's that, 3 and 4, 3/4. So rearranging the equation, p should equal to 1 minus 3/4. It's 1/4. Now that you know p, you can find n. N times p is equal to 1/4, or n is equal to 12 divided by p. So 12 divided by 1/4 gives you 48. So n is equal to 48, p is equal to 1/4, and then your final question is find probability of x equals 7. So how do you do that? How do you find the last bit? Probability of x equals 7. So success, I want 7 of them. You now know there are 48 trials, and chance of success is 0.25. Again, you can do it by hand or binomial PDF. Okay, so here I would have done binomial PDF, and n was 8. Probability of success is 0.25, and 48. And I want x equals 7. So if you type that in a CAS, you would have got it as your answer. Sorry for the rush. There was only about 8 minutes there. I guess we can type that on in a CAS and see what the answer comes up to be. Here we go. Binomial PDF. Let's do it. 48 trials. Probability of success is 0.25 or 1/4. And 7. I want 7 x's. So it should be 0.0389. Round to 4 decimal places would be 0.0339. Most times in your exams, they'll round probabilities to 4 decimal places. Okay. We'll pause there. The next one is interesting. If you want to have a go, you can. I think that where it will stump you is probably this page. So on the last page when it comes to ends. So if you want to have a go, you can have a go. But that's what I'll go through next session. Okay, so we'll stop there. Thanks, team. I'm going to stop the video.